Okay, let's talk about upthrust. So we have this object which is submerged in, let's say, water. So we know that the surrounding water will be exerting all these pressure forces on this object. Now, it looks like the pressure forces would cancel one another out, right? But that's not true, because the diagram is misleading. Remember, the pressure increases with depth. So the pressure forces at the lower heights should be stronger than the pressure forces above there. So a more accurate picture will look like this. So the resultant of all of these forces is actually going to be an upward vertical force. And that force is called the upthrust. So the upthrust is just the resultant of all the pressure forces. Get it? Okay, so now we know that the resultant of all these pressure forces is up. But what about the magnitude? For example, like this banana. What is the upthrust is going to experience? First, let me point out to you that it doesn't matter whether it's a banana or it's a banana made of brass or it's a banana made of styrofoam. All three of them will experience the exact same upthrust. Why? Remember, the upthrust is a resultant of all the pressure forces, right? So the pressure force, let's say at this point, will depend on the pressure at this point and the curvature here, which is the same whether it's a banana or a styrofoam banana or a brass banana. The surrounding water will have exerted the same exact upthrust on all three of them. So what is the magnitude of the upthrust? It has got to be smaller than the weight of the brass banana, right? That's why a brass banana will sink, you see? And it's actually lighter than the styrofoam banana. That's why a styrofoam banana will float. So it's something between the weight of the brass banana and the weight of a styrofoam banana. So what exactly it is? So we should be thinking of this question. What material should the banana be made of such that it will neither float nor sink? What material of banana will just hover in the water? And the answer is water banana. If the banana is made of water, it would hover there. It's obvious, isn't it? Because water should neither sink nor float in water. So what is the magnitude of the upthrust? It's equal to the weight of the water banana, or in more general, we'll say that the upthrust is equal to the weight of the water or the fluid displaced. Okay, let's see whether you have grasped these important concepts here. So there's this object here, it is partially submerged. It experiences upthrust that's the resultant of all these pressure forces. This object is fully submerged. It experiences the pressure forces by the surrounding, let's say, water. So what is the magnitude of the upthrust? So for this one, you should be looking at the displaced water. The displaced water. Because this amount of water would have been supported by the surrounding water. So that means all these surrounding pressure forces, the resultant magnitude is exactly equal to the weight of this amount of water. Likewise for this one, all these pressure forces, the resultant magnitude should be exactly equal to the weight of this amount of water. So get it? So this object, because it displaced this amount of water, so it should experience upthrust that's equals in magnitude to the weight of this amount of water. Get it? So same here, this object, because it displaced this amount of water, and therefore it should experience an upthrust that's equals to the weight of this amount of water. Amazing, right? That's all. Ta-ta!